In this Q&A video, we're going to answer the question, how do I add a remote start, stop and inch control to a DOL starter? Now, just before we explain the answer to this question, please be aware that this video is one of a series that we've made on the subject of motor controls in association with Crompton controls. They can be viewed individually, or you can click the link in the description below to view them as part of a free online training package to help you with your CPD, and you'll receive a certificate to prove that you've completed the course. In previous videos in this series, we've seen what a DOL starter is and how it can help us to comply with the wiring regulations by adding in a layer of safety when the power to a machine is removed and then restored. But we can use the starter to achieve greater control and convenience by extending the internal circuitry. First of all, we're going to look at how we can add a start and stop button at a location away from the contactor while still being able to use the controls built into the DOL starter itself. Basically, it's like two-way switching for lighting. Just like we can turn lights on and off from two different locations, we should be able to start and stop the motor from two different positions as well. Let's take the stop button first. We've seen that if the circuit is energized and the motor is running, then pressing this button disconnects the supply to the coil and stops the motor from running. Now, looking at the circuit diagram for this motor control, you can see that we could simply add another stop button. Remember, that's a button with a normally closed contact wired in series with this first one. That way, pressing either of the stop buttons will deactivate the motor. Now let's add in a second start button, which, as discussed previously, will be a normally open contact. Now remember, because we've got the control circuit wired through the auxiliary contact on the contactor, once the contactor has been activated, it should hold itself in the on position once we've removed our finger from the start button. Remember, we wired that auxiliary contact in parallel with the start button in a previous video, and so we apply the same principle to the additional start button by wiring it in parallel with the first one. That way, pressing either start button will activate the coil, completing the circuit via the auxiliary contact, and leave the motor energized when the start button is released. So we can now control the motor, both starting and stopping it from different buttons. To make it truly remote though, we can redraw the circuit diagram so that it looks like this. Notice we've taken three conductors from the original control point to the remote station. Two of these connect the start buttons together in parallel, the same as previously. Then we link the start button contact to the stop button contact. The third wire we brought from the DOL starter connects the two stop buttons in series with each other and actually brings the electricity into the remote station and feeds the start button here and back at the DOL starter as well. But to achieve that, you'll notice that the link between the original stop button and the original start button has been removed. If you leave that in, the remote stop button will not deactivate the coil and the motor will just keep running. Now, that's all well and good on paper, but what does it look like in real life? Well, let's install a remote start-stop control point for our motor here away from the original direct online starter. All you actually need to connect up the remote station is the three conductors, as we said a moment ago, plus a CPC if it's required. Two of the conductors connect either side of the start button in the direct online starter, and while we're adjusting the connections on the start button, we're going to remove that link to the stop button that we pointed out earlier, and we might as well hang on to that and move it to the remote start-stop location as we can reuse it there. Our third wire goes into the stop terminal where we just removed the link and then we move to the remote position. The conductor that we just connected to the output of the stop button in the DOL starter acts sort of as a permanent line and connects to one side of the stop button in the remote station. Then, out the other side of this, we bring the link wire we removed earlier to one side of the start button. Now, the two conductors that we connected either side of the start button in the original starter go either side of the start button in the remote position. But it's really important at this point that the conductor we connected to the coil activation terminal A2 goes on the opposite side to the link wire. Otherwise, the coil will be permanently energized and the motor will always be on. So, as you can see, we can start and stop the motor from both positions. And this principle can be extended to additional points as well, as long as we keep running those three conductors, connect start buttons in parallel, stops in series, and move the link between starts and stops to the last point of the circuit, it will all work the same way. There's additional clever things we can do with our DOL starter as well. One of these is what's referred to as inch control. So as we've seen in the last couple of videos, DOL starters are usually connected up so that we can switch a motor on, take our finger off the start button and walk away. But there may be times when we want the motor to run only when we have our finger on the button. An example might be a conveyor belt where we want to drive the belt a certain distance that we're eyeballing rather than using sensors, inching it along as it were, which is where we get the expression inch control. Now, to achieve this while still maintaining our start-stop control for general running, we need to apply a new button. But which type of contact will it have? Normally open or normally closed? Well, the answer is both. We mentioned in a previous video that we may come across stop buttons with two normally closed contacts to allow a bit of extra safety should one get locked up. Well, on an inch control button, there's two contacts, one of which is normally open and the other is normally closed. This normally closed contact is of a special type called an early break, late make contact. We'll see in a moment why it needs to be this way. Adding this arrangement to our remote start-stop position, you can see on the circuit diagram that when connected like this, the normally closed contact on the inch control allows the start circuit to operate as it did before, but now when we press the inch control and hold it down, the normally closed contact completes the circuit, triggers the contactor, and the motor will start. But notice too that the normally closed stop contact is now open as well. Then, when we release the inch button, there's a moment when the normally open start contact disconnects and the normally closed stop button is also open due to the fact that the contact is of that early break, late make type. The connection back into the stop part of the circuit is slightly delayed, and that means the coil loses power, the auxiliary contact opens, and the motor will stop running even when the normally closed stop contact closes up, meaning that you can hold the inch button down for as long as you want, even making relatively fine adjustments to the motor position. So there we go, that's how we add remote start stops and inch control to a DOL starter. To find out how a star delta starter works, check out this video right here, or click the link in the description below to view it as part of our free online training package to help you with your CPD, and you'll receive a certificate as well. All that remains in this video is to say thank you very much for watching.